Black holes, the insatiable dark monsters of the universe. Those gigantic cosmic vacuum cleaners that mercilessly swallow stars, planets, and even light crossing their path. For years in science fiction movies, we watched how helpless spaceships were drawn into that dark vortex. We were always told that black holes are the most dangerous traps of the universe, violently pulling in everything that approaches them. We even thought that if a runaway black hole entered our solar system one day, Earth would be sucked into that dark hole within seconds. What if I told you that this is actually a flawless Hollywood lie? What if black holes aren't the greedy monsters we thought they were? Today, we are going to shatter that big misconception about the most terrifying structures of the universe. The professor turns to the camera and slowly clasps his hands on the desk. On his face is that slight smile of someone about to reveal a great secret. First, let's do a small yet striking thought experiment in our minds. Imagine the giant sun standing right at the heart of our solar system, warming our planet, around which we have been orbiting for billions of years. Think that at this very second, a magic wand touches it, and the sun suddenly collapses into a black hole, with the same mass, the same weight, but now a dark point that no longer emits light. What do you think would happen to Earth? Would we immediately fall prey to that terrifying gravitational pull and get swallowed inside that spiral? The answer will surprise you very much. Nothing would happen, at least in an orbital sense. Earth would continue its silent and dark journey through space second by second, as if nothing had changed. Yes, because the sun's light would disappear, the sky would go completely dark, and our planet would freeze rapidly. But Earth would never ever fall into that terrifying black hole. How is that possible? How can this be? Because gravity is not a magical vacuum cleaner that hunts down distant objects like in the movies. The professor places a giant bowling ball on the desk, and then puts a tiny glass marble next to it. If you don't change the mass of the sun, you don't change its gravity. A star turning into a black hole does not mean it will suddenly start swallowing everything around it. It simply means that huge mass is compressed into an inconceivably small point. A black hole with the mass of the sun would have a diameter of only 6 kilometers. Since the mass remains the same, the force pulling Earth toward that center point would remain precisely the same. If the sun's gravity doesn't swallow us, why would a black hole with the exact same mass do so? The biggest mistake we make is confusing mass with volume. The danger of black holes doesn't come from pulling distant objects toward themselves, but from the possibility of getting much too close to them in a way you never could to a normal star. The real danger is not being pulled from afar, but getting far too close to that critical boundary through your own mistake. Well, since black holes don't pull everything in and swallow it from afar, what exactly did this legend of nothing can escape from inside and that famous event horizon mean? In the second part, we are embarking on a perilous journey toward that invisible line where time stands still, namely the event horizon. In the first part, we learned that black holes are not giant vacuum cleaners that forcefully swallow distant objects, and that even if a black hole replaced the sun, we would continue to orbit peacefully. But the story truly begins now, when you get way too close to that dark point. The professor slowly rolls the glass marble on the desk towards that dark spot. As the marble approaches an invisible line, it speeds up and suddenly vanishes from sight. This boundary, says the professor, is the event horizon, meaning the point of no return in the universe. A black hole has compressed its mass into such a tiny point that it bends the fabric of space-time almost like a bottomless well. This invisible line called the event horizon is where the black hole's gravity defeats even the speed limit, which is the speed of light. Since there is nothing faster than light in the universe, a beam of light crossing this boundary, a trillion-ton star, or a spaceship, can never return. But what you experience while crossing that boundary is not a huge explosion or annihilation in a giant blender, like in Hollywood movies. The truth is much stranger and more terrifying. Let's say you are falling toward the event horizon as an astronaut. You have a friend watching you from the outside. From their perspective, as you approach the black hole, you slow down, and when you reach the event horizon, you seem to freeze in place. That frozen image of yours slowly fades away, turning red over time. For you, time continues to flow completely normally. Sounds crazy, right? Because that massive gravity of the black hole bends not only space, but time itself. The professor opens both hands in the air as if stretching a rubber band. And there is also that famous physical end, Spaghettification, as scientists call it. Imagine falling feet first into a black hole. The unimaginably strong gravitational pull toward the center of the black hole changes so rapidly with distance that the gravitational force applied to your feet becomes millions of times greater than that on your head. Your body begins to stretch as if ruthlessly pulled by invisible giant hands. You take on a thin, elongated shape like a piece of spaghetti until you break apart down to your molecules and atoms. This is why black holes are not the predatory monsters of the universe. They are the extreme points of space-time, the ultimate dark laboratories where the rules of the universe and the limits of physics are tested. As long as they are far away from us, they are extremely quiet, blind, and harmless. They only show no mercy to those who do not play by their rules. That is, those who get unnecessarily close to that gravitational boundary. What did I tell you at the beginning of the video? The myth that black holes swallow everything is a cheap tale that simplifies this magnificent mechanics of the universe. Now, when you look at a black hole, you will not see a ferocious cosmic whirlpool pulling everything inside. You will see a massive silence that draws its own boundaries, bends time, and swallows only those who approach its own abyss. Physics teaches us not to fear the dark, but to understand the flawless and unforgiving rules of the universe. Now stop and think. If even black holes aren't lying in wait to swallow us as we thought, is what we should really fear in the universe the darkness itself, or the unforgiving rules of physics? Truly, now that we have shattered these misconceptions, are you ready to explore other false realities in the dark corners of the universe? If you liked this video and it opened a new window for you, don't forget to like my video and subscribe to my channel.